Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between data security and data privacy. Primary goal, protecting data from unauthorized access, corruption or theft. In data privacy, ensure proper handling and use of personal data according to user consent and regulation. Focus, data security, protecting the data itself, confidentiality, integrity, availability, CIA triad. In data privacy, protecting the identity of person associated with the data subject. Core mechanism, data security, encryptions, firewalls, access control, backups, intrusion detection system, authentication. In data privacy, anonymization, pseudonymization, consent management, regulatory compliance, GDPR, HIPAA, data minimization. Question answer, data security, who can access the data and how is it protected? Data privacy, what data is collected, why and how is it used, shared, breach impact. Data security lead to data loss, financial theft or system destruction, lead to regulatory fines, loss of public trust, and individual harm. Example, identity theft. Enforcement, data security typically enforced by IT security teams and system architects. Data privacy typically enforced by legal compliance and privacy officer. Relationship, security is necessary part of data privacy. You cannot have privacy without security. Data privacy governs the use and retention of data even if it is perfectly secure. Example, data security using an SSL certificate to encrypt data during transmission. Data privacy obtaining explicit user consent before collecting personal and location data. Moving to question, difference between cross entropy loss and mean squared error MSE. Primary use case, cross entropy classification problem, especially binary and multi-class regression problem predicting continuous values. Output type, cross entropy require the model output to be probabilities between 0 and 1. In mean square error, requires the model output to be continuous value in the range of target. Sensitivity to error. In cross entropy, penalize confident but incorrect prediction extremely harshly, steep gradient for large error. MSE penalize large error quadratically. The penalty increase with the size of error. Goal of minimization. In cross entropy, create convex surface for logistic regression softmax ensuring gradient descent find the global minima. In MSE, create convex surface for linear regression ensuring gradient descent find the global minima. Formula for binary L equal to minus y log y hat plus 1 minus y log 1 minus y hat. For MSE, L equal to n1 summation I equal to 1 n yi minus y hat I whole square. Vanishing gradient in cross entropy work well with sigmoid softmax. The log function help contract the vanishing gradient of the activation function. In MSE, when used, sigmoid can lead vanishing gradient when the output is saturated for from zero point 0.5. Interpretation, cross entropy measures the dimensionality between the true probability vector and predicted probability vector. In MSE, measure the average square distance between the predicted value and the true value. Moving question, difference between causality and correlation. Causality, a relationship where a change is one variable A produce the change in another variable B. Correlation, a relationship where a change in one variable A is statistically associated with change in another variable B. Direction, in causality, A cause B, or B cause A, or C cause both A and B. In correlation, no directional simply indicates how strongly two variables are related. Measurement causality established through controlled experiment RCTs, instrumental variables, or advanced causal inference model. Correlation measured using the correlation coefficient R or covariance goal. Causality to understand the underlying mechanism and enable actionable policy intervention. Correlation to enable prediction. Example, if increases, what is the expected value of B? The risk. Causality incorrectly assuming a correlation in causal. Example, famous ice cream sales cause drawing for flashy. Correlation, mistaking a causal link for mere corrections. Correlations, less common but still possible. Statistical role. Causality, the domain of causal inference and econometrics. In correlation, a core concept is descriptive and predictive statistic and standard ML model. Causality, standard predictive ML model typically only capture correlation. Correlation, standard predictive ML model are built entirely on the correlation. Please like, subscribe and share the channel. Thank you.